So what is access modifier? This is one of the most important topic in OOPS and in C# programming language. And this is asked in a multiple interview question. They can ask this question like explain the access modifier or what are the different types of access modifier available in C# or what is the role of access modifier in C#. So we'll discuss all those topics now. So what is access modifier? It is used to specify the accessibility of a member, that is field and method, or a type, that is class and interface. It supports abstraction by exposing only necessary members and hiding other members. Remember we discussed abstraction in our first slide, like what is abstraction? It's the building block of OOPS concept. So the access modifier can be used to support abstraction, and it only exposes the necessary member and it hide all the other members from a C# program. In C# programming language, there are 5 different types of access modifier, and they are termed as private, protected, internal, protected internal, and public. Students normally get confused with this internal and protected internal. So please pay attention when we discuss these two topics. But you can see that these are the 5 types of access modifier we do have in C#. And again, this can be asked in an interview, like what are the different types of access modifier? So in that case, you have to answer this question that there are 5 types and they are protected, private, public, internal, and protected internal. Let's discuss this access modifier one by one in upcoming slides. So a question again, a different types. The first is private. A private access modifier can be accessed inside the same class or a struct. So this is having the least exposure. So whatsoever you declared as private can be accessed in the same class only. It cannot be exposed to the outer class. If I create an object of that class, that would be known that we cannot access that because that is termed as private. The next is protected. The protected can be used or accessed inside the same class or in derived class. So suppose if I declare something as protected, this can be used in the same class and again in the derived class. We have already learned the concept of inheritance and the concept of base class and derived class. So protected is used in that concept, the concept of inheritance. The next is public. As the name suggests, public can be accessed inside the same assembly or any other assembly that references it. In short, you can say that a public is having a least restrictions and they can be accessed approximately anywhere. The next is internal. Internal can be accessed inside the same assembly but not within the another assembly. So suppose if I've created a project file and a project consists of, let's say, an employee. So although all those properties and field that are defined as internal can be accessed in the same assembly anywhere inside it, but they cannot be go outside the same assembly. Like if we just inherit a DLL or if we just get a DLL and use it somewhere else, so internal won't be accessible over there. We can use public over there. And finally, we do have a protected internal. Again, that can be asked, that can be accessed inside the same assembly or inside a derived class and another assembly. So please pay attention. Both internal and protected internal, they can be accessed inside the same assembly. So you can say that both internal and protected internal can be accessible in the same assembly, but there's one difference in this. Internal cannot be accessed in the other assembly, but protected internal can be accessed inside a derived class in another assembly. So this is the two important topic, and these ask interchangeably in an interview, like what is internal and what is protected internal and how they are accessible and how they are difference in their terms of accessibility. So these things can be used to answer your question about the internal and protected internal. So I hope this clear all your concepts about the access modifier. And this is the most important topic, not even not from the interview perspective, but in general as well. So whenever you write a code in C# programming, in each and every method, you will came across with these access modifier, and you have to choose which one we have to use as per your business requirement and your class designing hierarchy. So this is all about the access modifier. Now let's move to our next topic, that is explain the access modifier's accessibility. So in this class or in this table, you can say that how these access modifiers are used over here. So you can say that private is the least accessible and that can be only used in the same class. It cannot be used in derived classes, other classes, or even not in different assembly as well. Protected again can be used in the same class and derived class, but it cannot be used in any other class. So if we do have a parent class and a child class, then protected can be used, but it cannot be used in another class. Protected can also use in a different assembly derived class as well. Internal can be used in the same assembly only. So remember we discussed that internal cannot be used in a separate assembly. So that's why you can see that these things are termed as no, and internal can be used in the same assembly. Now protected internal, they can be used in the same assembly as well as in a different assembly but with a derived class. So protected internal can be used in the same class, a derived class, another class, and in a different assembly as well, they can be used in a derived class. And finally, there is a public, which is having the least restriction and they can be used anywhere. So these are the access modifier accessibility explained over there. Now let's move to our next topic, that is how to use access modifiers in C#. As I told you that whenever you write some code, you will came across this topic like how to use it, and that totally depend upon the business logic that you want to implement. So we'll try to give you a brief idea like how access modifiers are used in this slide. So you can see that we have created a class named as access modifier, and we have declared some of the field like private int and public int. You can see that they are termed as private and public. Again, we have created a few more field, that is protected, internal, and private protected int. And in this print access modifier, we are using all those fields. Like we are printing the value of all those fields on the console. In the first method, we are printing the private int, then this public int, then protected int, then internal int, and then private protected int. So let's understand how this class can be used in and next slide, and how we can access these objects. So we have declared a driver function or a calling function, and that is a static void main. And here we have created the class object using the new keyword. So access modifiers is equals to new access modifier, and this class, this object can be used to retrieve the value that is available inside this class. So in the first line, you can say that we are printing access modifier dot private int. So in the previous slide, we have seen that this private int is declared as private, so we won't be able to access it outside the class as per definition. And whenever you write this statement access modifier dot private int, that will throw an error. We can access public field because the public field is having a least restriction. So whenever you write access modifier dot public int, it will print the value of a public field, that is 20 in this case. We can access protected field as well using the same concept, and it will print the protected field. And we can access the internal field as well using the same concept, and it will print the internal field as well. And right now we are accessing the method over here, that is print access modifier, and it will print all the values that we have declared inside this method in the previous slide. So this is how access modifier can be used in a C# program, and which one we can call it outside the program, outside the class file, and which one we cannot. Now let's move to our next topic, that is its output. Like how, let's understand the output of this particular implementation. So you can see that the first output is 20, which is the public int. The second is 30, which is protected int. The third is 40, which is internal int. And then we are calling this method print access modifier, which is printing all the different lines of statement that we have written inside this method. So this is how the access modifier can be used in C# programming. Now let's move to another topic, constructors. So what is a constructor in C#? A constructor is a special type of function and method which has the same name as its class. This point I have already covered that a constructor name is have to have similar with the class name. There is no exception in that. Whenever you declare a constructor, its name should be a class only. It is invoked automatically whenever you create an object of that class, and it is responsible for object initialization and memory allocation to its class member. So you have seen this in the concept when we were discussing about an object. So whenever you create a class object, a constructor is invoked automatically, and the responsible of constructor is to initialize the object and provide the memory allocation to its class member. Constructor does not have return type and not even a void type, and it supports overloading. So constructor supports overloading, and there is no return type of constructor. It doesn't return anything. This is how we can create a constructor. So you can see that over here we have declared a class name as car, and we have declared a constructor as a same name of class car. You can see that we have not passed something over here, and that is termed as default constructor. So we will use this concept later on, like what is default constructor or what is parameterized constructor. But from this point of time, you can say that this is how a constructor can be created, and the name of the constructor is similar to the name of a class. Now let's understand the different type of constructor that we have in C# programming. So in an interview, it might be asked like explain the different type of constructors. So the answer is there are four different type of constructor available in C# programming. The first one is default constructor, which we have just seen, where we are not passing any parameters. And whenever you create an object of a class, that will be invoked, and there's no need of even writing a default constructor. That comes automatically whenever you create a class. The next is a parameterized constructor, where we pass certain parameters like first name and last name. Then we do have a static constructor as well, and a private constructor. So a private constructor is having a specific use case we'll discuss later, but you can, as of now, you can see that there are four types of constructor: default constructor, parameterized constructor, static constructor, and a private constructor. We do have a copy constructor as well, but that is out of scope. From this point of view, you can see that there are only four types of it. So let's understand these four types one by one in upcoming slide. What is a default constructor? A default constructor has no parameters. When a class has no constructor, the default constructor is served by the compiler to that class. Remember, we discussed that whenever we create an object, a constructor is invoked. And suppose if you have not created any constructor in a class, then a default constructor would be already there. And it serves the purpose by the compiler of that class. It has no parameter, and that's why it is called as a default constructor. It is used to assign a default value to instance variable of that class. So let's understand this with example, like how can we create a default constructor. So you can see that there is a class name as example, and we do have two fields over here, num1 and num2. In this way, we can declare a default constructor. So you can see the constructor name is same as the class name, and there is no exception in that part. A constructor name would also have a similar to class name, and since we are not passing any parameter inside it, so that's why it is called as a default constructor. Whenever we create an object of this example class, this default constructor will invoke first, and it will display on the console like this is a default constructor. Now next topic is parameterized constructor. So what is parameterized constructor? The parameterized constructor has one or more parameters. It is used to assign value to an instance variable of that class. For example, so in the same say, you can say that the same class example, we do have a parameterized constructor as well, and it takes two input as a parameter of it. That is int a and int b. and inside it, it assigning the value of two input to its internal field, that is num1 and num2. So parameterized constructor has one or more parameter and it is different than default constructor. So you have to declare parameterized constructor explicitly in a C# program. This can be asked in an interview, like how can you create a parameterized constructor or how can you use a parameterized constructor? So you have to say like this. In order to create a parameterized constructor, we have to pass some parameters to its nature, and that parameter can be used anywhere else in the program if we assign its value to some internal field. This. So far we have discussed default constructor and parameterized constructor. Now let's go to the next topic, that is private constructor. So what is a private constructor? A private constructor restricts a class to create an object having a class with private constructor, but we can create the instance of this class. Suppose if a class is having a private constructor, so no other class can create the object of that class, but a nested class of that private constructor class can be used to create its object. In C# 1.x, there was no static class, so developer used to create a private constructor to prevent a class external instantiation. A class can have multiple private constructor and public constructor. The example of private constructor is, you can see again that we have created a class named as example, and then there is a private constructor, and then there is a method over here, that is a method 1. So private constructor is useful when you don't want a class to create an object of another class. In an interview, it might be asked like, what is the use case of a private constructor? Why someone wants to not to create an object of their class? The private constructor is heavily used in singleton design pattern. So you can answer it this way, like private constructors are used in single design pattern where we do not want to create an object of our class. And in order to prevent other classes to create an object, we use a private constructor. Our next topic is static constructor. So what is a static constructor? It is a constructor that gets called before the first object of that class is created. So whenever you create an object of that class, a static constructor is the first one which get invoked or which is called. It is used to initialize any static field or to perform action only once. Now please pay attention on this line. So a static constructor can be only called once. If you create a multiple object of a same class, the static constructor will be invoked for the first time, and for the rest of the time only the default constructor will be invoked, and it is used to initialize any static field. So this can be asked in an interview, like what is the practical use case of a static constructor? So you can say that it is used to initialize a static field. Can be asked in this way as well, like how many times a static constructor is invoked whenever you create a multiple object of a class. The answer is only once, because a static constructor execute only once in a program whenever you create an object of it. A class can have only one static constructor, and it must be a default constructor and having a no access modifier. Now here it comes to a three questions that can be asked around this particular statement. So how many static constructor a class can have? A class can have only one static constructor, and that should be default only. We cannot have a parameterized static constructor. A static constructor should be default only, and it should have no access modifier. That is, we cannot use public, private, anything in the front of a static constructor. It should have no access modifier and should be default only. Let's understand the static constructor with the help of a pseudocode. So here you can see that we have created a class named as program and a class named as car. A car is having a static constructor only. It is not having a parameterized constructor, but as we learned in the previous slide, that a class can automatically have a default constructor. So though we have not created the default constructor over here, but that is available in this class and will be invoked when we create this class object. In the driver class or the caller class, we are creating the two object of a class, that is user and user1. And then in the end, we are printing the statement on the console. So whenever we execute this method and whenever the user will invoke, or whenever this line of code will be invoked, it will internally invoke the static constructor, and on the console it displays a message that is a static constructor called. But in the next line, whenever you use a user one object, then there would be no execution of static constructor because a static constructor perform action only once. So if there would have been a default constructor, that would be execute no matter how many number of times you create the object of that class. But for static constructor, it is execute only once. So this is all about static constructor, and this can be asked in an interview, and it's very important interview question because most of the folks that are learning C# programming, they skip this part because normally we don't use static constructor in any program. But from interview perspective, you can say that yes, this is the one which can be asked multiple times. Our next topic is the order in which the constructor will be called. So like suppose we have learned the concept of inheritance, and we have seen like how the classes can be acted as a base class and a child class. Now we will understand like if we have a base class and a child class, and if both the classes having a constructor, then how these constructors are called. So when you create a child class object, first it's a base class constructor is called, and then its constructor is called. So please pay attention towards this line. Suppose we have a class, a base class and a child class. When we create a object of a child class, so let's say when we create an object of it, first of all, the constructor of base class will be called. There is no exception in that part. So whenever you create a child class object, a base class constructor will be executed, and then a child class constructor is called. Let's understand this with the help of a pseudocode. So here you can see that we have created a base class and it's only having a default constructor, or you can say non-parameterized constructor, and it's printing a message that is base class constructor. We do have a child class as well, which is inheriting from the base class using this symbol that is used inheritance. And then we create a child class, and again the child class is having the same default constructor, and it is printing a message as a child constructor called. Now here we are creating a child class object. We are not creating a base class object. You can see child class child object is equals to new child. So when compiler reach to this particular line of code, it will first of all execute the base class constructor, and initially or in the first statement, this line will be printed in the console because this is something which is printed in the base class, and then it will execute the child class constructor, and the statement will be printed as this one. So let's see the output of it. So when you execute this, the first of all the base constructor called, that is the first statement, and second the child constructor called, that is the second statement. So with this topic, we covered the constructor section in this slide, and you can say that there are different type of constructor and they can be used in different scenarios.